researchers have unveiled Optimus One, a groundbreaking AI agent designed for long-horizon tasks. This hybrid multimodal memory-empowered agent excels in open-world challenges. It transforms knowledge into a hierarchical directed knowledge graph, enhancing world knowledge representation. Historical data is summarized into an abstracted multimodal experience pool, aiding in context learning. Optimus One features a knowledge-guided planner and an experience-driven reflector for improved planning and reflection. Tested in Minecraft, it outperforms existing agents on long-horizon benchmarks, showing near-human-level performance. The agent utilizes multimodal large language models as its backbone, demonstrating strong generalization. Optimus One is a significant leap forward in AI capabilities. In the field of digital pathology, semantic segmentation is crucial for diagnosing tissue lesions. Traditional models like SAM and SAM2 excel in instance segmentation, but fall short in pathology. A new model, SAM2Path, addresses this gap. It integrates a Kolmogorov-Arnold networks classification module and a large pre-trained vision encoder for histopathology. 2Path autonomously performs semantic segmentation without human input prompts. Experiments show it achieves competitive results on public pathology datasets. The code is open sourced for further exploration. Researchers introduced SpeechMassive, a groundbreaking multilingual dataset for spoken language understanding (SLU). It includes speech in 12 languages, enhancing the massive textual corpus. This dataset addresses the need for diverse SLU data to test foundation models like LLM and speech encoders. SpeechMassive offers a multimodal, multitask, multilingual approach. It provides benchmarks for speech transcription, language identification, and translation tasks. The dataset models and code are publicly available for further research and development. Researchers have developed a new method called SCORE to enhance the self-correction ability of large language models. Traditional approaches have been ineffective, requiring multiple models or more capable ones. Reinforcement learning with self-generated data to improve self-correction. It overcomes issues with distribution mismatch and limited correction behavior. RE introduces a two-phase training process with regularization to ensure effective self-correction. When applied to Gemini models, it achieved significant improvements in self-correction performance. This breakthrough could revolutionize how language models learn and correct themselves. Introducing Oryx MLLM, a breakthrough in multimodal architecture. Designed for spatial temporal understanding, it processes images, videos, and 3D scenes. Traditional LM standardized visual inputs, but Oryx offers on-demand processing at any resolution. It features a pre-trained Oryx VT model for versatile visual encoding and a dynamic compressor for efficient token compression. Oryx excels in long visual contexts, like videos, with high precision for tasks like document understanding. Its capabilities are enhanced through specialized training and data curation. Oryx work is open-sourced, making it accessible to all. Experience the future of multimodal understanding with Oryx MLLM. GameNGen is a revolutionary game engine powered by neural models, enabling real-time interaction with complex environments. It can simulate classic games like Doom at over 20 frames per second on a single TPU. The next frame prediction boasts a PSNR of 29.4, comparable to lossy JPEG compression. Human raters struggle to differentiate short clips of the game from the simulation. GameNGen is trained in two phases. An RL engine learns to play the game, and a diffusion model is trained to produce the next frame based on past frames and actions. This engine can perform complex game state updates and persist the game state over long trajectories. GameNGen represents a new paradigm for game engines, where games are automatically generated by neural models. The engine uses DDIM sampling and classifier-free guidance for past observations. It can robustly simulate Doom with only 4 DDIM sampling steps. GameNGen achieves high simulation quality comparable to the original game over long trajectories. Human raters can barely distinguish between clips of the simulation and the actual game. The engine's performance is superior to models trained on random trajectories, demonstrating the importance of agent-generated data.